welcome to MacMind.io. My name is Johnny Mac. I am a software professional and the host of this channel. Thank you for tuning in today. I'm really excited to share with you about how to set up and configure a custom image for your Raspberry Pi using the RPI Image Gen tool. Be sure to watch all the way through to the end of this video. Once you learn the basics of how to build a custom image, I'll show you how to set up and configure the tool to build an image that has auto login enabled. But first, why would you want to build a custom Raspberry Pi image? And why would you want to use the RPI Image Gen tool versus just creating an image from the device state or using the RPI distro PiGen tool? So if you're a home hobbyist and you're looking to set up a home media center or a home automation controller to power your holiday light show, you're probably going to install the Raspberry Pi operating system. This is a full desktop experience with all the drivers that you need to power your monitor, your keyboard and mouse, your Wi-Fi, your Ethernet, and your Bluetooth. It takes a lot of the guessing out of the equation, and it's a really nice user experience, and it's very familiar, and you can get going with setting up and configuring your home automation or your home media center. And that's going to be great. You're going to use the RPI Imager tool, and you're going to go ahead and you're going to pick from the list, and it's right at the top of the list. And you're just going to install that on your USB or your SD card. And that's going to be great. So you don't have to worry about much. And that's where you get started. However, if you are a production professional or you're pursuing a project where you want to use the Raspberry Pi as hardware for a production product, maybe it's digital signage or a kiosk, which is increasingly common since the Raspberry Pi now, after 10 plus years, has had a very reliable and high quality reputation for building electronic devices. And it's actually being used to power a lot of devices in production. And so you may not realize this, but you're driving down the road and you see a big billboard that has digital images that are showing advertisements. That might be powered by a Raspberry Pi. Or maybe you're at the airport in a kiosk that may be powered by a Raspberry Pi. And so if you're working on one of these projects, you want to start thinking about how to develop a highly customized image and user experience. Things like a splash screen, auto login, a single app device. You want to think about security implications for your project, maybe limiting hardware or network access. You want to think about how to change the file system type. Maybe you want to limit the overall size of the image to reduce your production costs. And maybe you want to generate a software bill of materials for that device so that you know whether or not you're vulnerable to any sort of security threats that come out that are potentially an issue for you and your product. And lastly, you want to probably learn how to iterate quickly to build these images, right? You want to build a gold master image that you can then mass produce. It's going to be important for you to have a development life cycle where you can quickly restore state and test, and then be able to produce a gold master image for the device. And so if we look at the different ways that you can go about this development, what we see is that first one that we're talking about is looking something like this, where what we do is we take an SD card, we put it in our laptop, we use the Imager tool to install that on the SD card. And now we're going to put that into the device itself, and then we're going to configure the device, right? So we get that gold master image. That configuration in this workflow is very manual, and we probably don't want to have to remember exactly all the steps that we took. So what we're going to do is try and write some scripts to replay those steps that we took manually, and then finally we're going to use those scripts and run them on top of that base image, and then we get our gold master image. And so this is a very popular and common workflow, but you can see that it is lengthy and requires you to transfer those scripts onto the device after you have your base image installed there, which means you have to have networking set up and copy the scripts over and run them. And it's also just not ideal to start with that base image that you don't really know what's in it. This is akin to whittling an image to some state that you want it, right? And so if we think about whittling, we think about wood, and you have a block of wood and you whittle away the wood. So that's the workflow that we are looking at right here. However, as an alternative to that, instead of whittling, what if we could actually cast the image, right, from a set of specifications that we define? And what would that look like? So that would look something like this, right? Where instead of using the imager and installing a base image, we're just going to use RPI Image Gen to build our gold image. And then we're going to use the tool to put that image on our SD card, and we're done. So that's why we're looking at this option instead of using the device state to build our image. So with that explanation of why you'd want to do it this way, let's go ahead and look at the different options of how you can build a custom image. And we'll start with the RPI distro PyGen tool, which is a tool we see here is used to create the official Raspberry Pi OS images, which includes the image that I showed you earlier that is at the top of the list when you use the RPI imager. And we see here that this is a tool. It's been pretty actively developed. It's got 2,800 stars, 1,700 forks. It's got this staged development workflow. So if we look in here at the various stages, you can add customizations to these stages. And that's how you ultimately configure the tool to generate the image that you want. Again, this is used to create Raspberry Pi images. We can see there's some more information here. And really, this is a viable tool for the workflow that I'm advocating for to generate a custom image. However, when I was looking into utilities for this purpose, I found this one, but also discovered something called RPI Image Gen. And when I look at that tool, I see that it's hosted by the Raspberry Pi organization, and it claims to be a tool to generate highly customized software images for Raspberry Pi devices, which sounds exactly like what I'm trying to do. So why is this tool been developed, and why is it different, and how is it different? If we're looking here, what we can see in perusing the repo is a legacy directory that looks surprisingly like the PyGen tool that we were just looking at, right? We see almost the same exact folder structure. And so that's a clue that maybe this is inspired by the PyGen tool. And if we look at the Raspberry Pi organization, we can see that they have a number of repos that they are managing, and this is now on that list. So if we scroll down a little bit more, we can see that there's actually a call out to why to use this right here. And the claims are that it's quick to build. You don't have to build the whole world from source. I interpret this to mean if we're using another tool, we're actually going to compile some of the binaries, and this tool instead just sources binaries that have been pre-built because we know what the hardware is, right? And so we can also then configure your file system exactly how you want it using RPI SP Provisioner. And then we also get a software bill of materials using this tool, which is going to give us a list of CVEs identified from the SBOM too. This is great. When I'm looking at starting a project and using open source software, I'm always looking, okay, what is the pulse of the project? And is this something that is under active development? And is this a new way of doing things? Because if I'm going to be using something and investing in it, I want to think about the long term. And if this RPI distro PyGen tool is a practical way to implement my solution, but this RPI Image Gen tool is now coming online, even though it may be a little novel, if this is be a superior way to do it and then going to be a longer lasting way to do it, that's something that I want to explore. And so that's how I approached this. I wanted to understand if this is going to work or not. And so that's where I began. So let's set this tool up and try it out. So when we look at the docs here, it says that the RPI Image Gen runs best on a Raspberry Pi host running up-to-date 64-bit Raspberry Pi OS. That's great. I really don't want to use my Raspberry Pi and install the Raspberry Pi OS and then use it to build images. I want to build them on my Mac and then install them on my Raspberry Pi. And right off the bat, what comes to mind is maybe I can use Docker to simulate the Raspberry Pi OS and build the images using that. And so when we look at the Raspberry Pi 64-bit OS, what comes to mind is this line from the RPI distro PiGen tool, which shares that Raspberry Pi OS 64-bit images are primarily based on Debian. Great. We can build a Debian-based image for Docker, and we ought to be able to run that and build the images for the Raspberry Pi using this tool. And let's go ahead and look closer then at what are the dependencies that we need in that Debian image. And sure enough, this tool does a great job at sharing what those dependencies are. There's a depends file here, and what we see is a list of dependencies that the tool needs. And if we come back here, we see the TLDR, okay, clone the repo, install the dependencies, and run build. This will essentially build the default image that the tool is configured to build. So we ought to be able to do this. So let's open the terminal up, and we're going to go create a Docker file. And again, we're going to source the base image from Debian. And then we're going to install from that list of dependencies. Now I'm going to skip ahead a little bit here, and I did go through a bit of iterating and discovered a few more dependencies that I did need to install, which is maybe not a surprise. You know, that base Debian bookworm image didn't have everything that I needed, but I'll go ahead and publish this Docker file for you, and here is that list of dependencies that needed to be installed. And then I am going to go ahead and skip ahead again a little bit here. And I also needed to install a GPG key for installing the packages from the Raspberry Pi repository. And then finally, we do need to create a non-root user. And then I'm going to go ahead and install the utility. Now I'm going to pin here to a specific Git SHA on the main branch because there isn't actually a tag right now. The project is very novel and under active development, but this just makes it so that my image is pinned to a specific version of the code and it's not a moving target for me. So with that, I ought to be able to go ahead and run this. Now I'm also a Docker Compose person, so I'm going to go ahead and also create a very simple Docker Compose file for this project. And that's going to look something like this. Okay, great. And now I ought to be able to build this image. Awesome. Okay, so that was pretty quick. Spoiler, there is some caching there, but I assure you this is a very quick image to build, even if you're pulling it from scratch. And now I ought to be able to go ahead and run this image. Okay, great. So now I'm here inside a Docker container that is running a image with the Debian base and the dependencies that were recommended. And I should, in theory now, if I look and see, I have the RPI Image Gen utility, and I should be able to just, if we look back at the instructions here, I should be able to go ahead and just run build. I've already installed deps, so if I do the build, then this should get going. Let's give it a shot. And there it goes. Okay, we can see we're building an image. Now, we're not really building a custom image necessarily because we're just building the default image that this tool is configured to build. But what we've established is that we can actually run this utility in a Docker container on our Mac without too much of a hassle. And that's a great step to have achieved. Now we have some confidence that we can use this tool and that we can actually run it. And we can see that it's pretty fast. We're watching it move right along here, and without too much effort, it's already into the phase where it is generating the images, and now it is nearly completed, and just like that, it's done. So that quickly we were able to build a custom image, and we can install this on our Raspberry Pi. Now I'm gonna forego that step here because if we look closer, it says here in the notes that there is a default image intentionally has login passwords disabled. So we wouldn't actually be able to log in. That's not going to be very interesting. And it's also not really a custom image in the sense that it's just the default image. So why don't we go ahead and configure the tool to build an image that supports a login. And we're going to do that by coming over here and looking at a very simple example that's provided in the repo called set options. And I'm going to go ahead and copy that example from the provided examples to my home directory. And we should see that there now, set options, okay? And so now if I come into set options, I can see a very simple my options directory, okay? And it has things like device host name and user pass. So let's go ahead and configure this. Now in order to do, I'm gonna need to install an editor inside my container. And so to do that, I can just go ahead and apt-get install nano. And I think I will need to also do some upgrade. Okay, so we're doing this. Okay. Great, so now I have nano and I can nano my options and come in here. Okay, it's the fraudulator. That sounds like a good enough name. Let's call the user, nice. Let's change the host name from fraudulator to MacMinds. And user MacMind, password MacMind, not the most secure. And image name is going to be MacMinds also. We can go ahead and write that out, save the buffer. Excellent. Okay, so now what we should be able to do is build an image, and we should be able to specify the options as coming from set options, my options. And if we build this, now we would expect it to build an image that has the MacMind user with the password of MacMind. And again, we can make this change. We can go ahead and rerun the tool. And so long as we aren't changing, if we do want to rerun it in the same container instance, we are going to need to delete and remove the artifact directory, the working directory, that we made. The tool checks at first, is there already an active working directory? And if it doesn't, overwrite it. So it makes you explicitly delete that. But again, we can just rerun this thing over and over and generate images, and they can then be tested on the device. So we're almost done here. Great. Now we have our images. Now the image we just built is inside the Docker container that is running. And if we want to use the Raspberry Pi Imager tool to copy that to an SD card or a USB stick on our Mac, then we need to copy it outside of the container to the host. And that's facilitated fairly straightforward. We can come over here and use Docker to do that. So we'll go ahead and get the ID of the container that is running here. Okay. And then we're going to go ahead and use the Docker copy command. And we're going to copy the full absolute path of the image inside the container. And we're just going to go ahead. I have a directory on my host machine called RPI Images, and I'm going to go ahead and copy that there. Okay. And that's done. So now I ought to be able to take my USB stick and install this image onto it. So why don't we go ahead and give that a try. And so if we come back here, we can see I have my USB stick here. It's a pretty tiny little guy. This is a 32 gig SanDisk USB stick that I've been using for this project. I'm gonna go ahead and stick that into the USB drive on my Mac. And I'm gonna call up the Imager tool here. And now what I'm going to do is I'm going to choose device. I'm not sure the implications of choosing device here. I go ahead and choose the Pi 4 that I have, and I can go ahead and show you guys the Pi 4 that I have, which is going to look like this. And I actually have it attached to this little 4-inch screen too. But this is a Raspberry Pi 4. You might be familiar with it. And so I'm going to go ahead and image that. Now when I come in here, instead of installing the recommended operating system, right, I'm going to scroll down and we see lots of other options here. And this is actually like a marketplace of operating systems that have been curated for specific purposes. Using a tool possibly like RPI Distro PyGen or the first workflow that I showed you to generate those images. But we're going to scroll down and use custom. And there's our image right there, MacMinds.image. And we ought to be able to then choose storage, and we see this SanDisk media. And then we click next. And would you like to apply OS customization settings? I'm going to go along and say no. I don't want any customization settings there using this tool. I've already got all the customization that I want using the RPI Image Gen tool. Okay, confirm that the media will be erased, no problem. Give it my password, and off I go. Now it's writing to the disk. And again, this is depending on the speed of your peripherals, a fairly quick, and the size of the image, a fairly quick process, and shouldn't take too long. While that's going on, I can go ahead and show you a little more from the repo. And you're going to want to go ahead and take a look at the examples, right? This is a great way for you to learn the interface, right, that this tool is providing. And so most of the examples are going to share with you the interface in the README, right? For example, we have the set options, and we're just seeing exactly what we did, right? We passed it the options file. But as things get more sophisticated, maybe here's a slim image example, the structure is going to get a little more complex, and the command is going to get a little more complex. And so what we'll do, as promised after this, is I'll show you one configuration to configure the auto login for the device. And if we come back here, we see we're in the verifying stage now, and this is almost done. And we can see that how quick this is, right? And this is going to allow us as developers to iterate quickly, right? We can build our image, put it on this card, put it in the device, and see if it works, and then iterate in that manner, so that we're not trying to whittle, right? We're casting the image instead of whittling from a base image to get the result that we want. And so with that, this is nearly completed. Finalizing. Okay, excellent. The write was successful. Now we continue. Okay, I'm going to go ahead and take the USB stick, and with the image on it, I'm going to plug it in here to my Raspberry Pi. Okay, like that. And I'm also going to attach my keyboard here that I have. And let's power this guy up and see what happens. Okay, so we have, it looks like it's booting. Okay, and excellent. And there you go, MacMind's login. Okay, so we ought to be able to go ahead and log in with MacMind. And there you have it. Okay, so now we're logged in. All right, to the device. Pretty cool, huh? Okay, so what were we able to accomplish so far? We were able to identify why we would want to build an image using an image generation tool rather than whittling a base image that comes as default or option with the RPI imager. We were able to run the RPI Image Gen tool in a Docker container and successfully configure an image with some custom login options. And so that's great. But the image itself that's running is the default image that comes with the RPI Image Gen tool. And so what we want to do is learn how to get slightly more sophisticated. So as promised, what we're going to do next is learn how to configure auto login on the device. Okay, so if we want to set up auto login for our device, Let's go ahead and come back over to the terminal. And what we're going to do first is just exit out of the container that we're in. Docker containers are ephemeral, so everything that we were doing in there is going to be deleted unless we set up some persistence using a mounted volume, which we didn't do. So we're going to go ahead now and run another instance of this image, and we should see we don't have that set options directory anymore. Okay, and so what we're going to do then is follow that same model and go ahead and copy over the examples and set options here, and we're just going to copy it into a directory, and we're going to call this MacMind. Okay, so this is going to be our external directory. When we look at the project in RPI Image Gen, we start to get a sense of how this is going to work. Okay, so when we scroll down here, we see some terminology: device class, config, profile, image, meta, these terms. And if we scroll further down, we look at this directory hierarchy, and that's going to be important, right? So this extdir is going to be a directory that we specify that will include some subdirectories, or if we don't specify anything, it's just going to use the top level of the project repository. And so when we built the image prior, that's what was happening. The build tool was just using this top level directory and sourcing the configuration that it needed from these direct subdirectories: config, device, image, meta, profile. Those are the subdirectories that it was referencing when it was doing that build. And so we want to now set up some customizations, right? And so what we're going to do is we're going to head back over here into our terminal, and we're going to copy the top level image directory into our MacMind project. Okay, and we do that, and now we have an image directory, and when we come in here, we can see that it has some additional subdirectories. We're going to go ahead and remove the GPT directory because we don't need that, and I'm going to try and keep things simple. And we're also going to move this post image shell script into MBR simple, and the reason for that is that if we don't, then it won't run. It only runs if it's in this location, if the image directory is part of the top level. I'll spare you the details there, but you can trust me on this one. Okay, we're going to come back, and let's go ahead and change the name of my options to MacMind options. And then let's go ahead and install Nano again. Remember, when we built the container, we did not retain Nano. So we'll go ahead and install that again. Okay, great. And if I open this options file, I can go ahead and I can reconfigure these variables. MacMind, MacMind. Okay, we can work that out. Okay. So now we have an image directory and we have our options. So something that we're going to need to do is we're going to need to create a config for this project. And that is facilitated through a config file. Okay, and this is just going to be a simple configuration, and you can explore some of the examples, but for the purpose of this, we're going to just go ahead and classify the device as a Pi 4, and we're going to source a profile from Bookworm app min64. Now what this is going to do is it's going to source the profile from the top level directory, because we aren't going to specify or include a profile directory in our project. So whenever you don't have a directory in your project, whether it be config, device, image, profile, or meta, that will be sourced from the top level if it's not in your project. And so if we look in the profile, we can see Bookworm and APT min64. okay? And this is just going to be a reference to some YAML that is going to be used to configure the image. And what we can do in another video is get into the details of how all that works. But for now, we're just going to go ahead and specify that this is the bookworm aptmin64. Okay, we're going to name the device MacMind, and then we're going to source the layout from our MBR simple directory. Now this, because we do have an image directory in our project, we need to make sure that the layout includes this directory structure. So we copied over from the top level and we included this MBR simple dual configuration. And we did that because we're going to now go ahead and add configuration there so that we can auto log in the MacMind user. Okay. So when we do this, you can see that we have these pre and post image and build scripts, okay? And so what we want to do is we want to add a post build script that's going to configure the auto login on the device. And so what we can do then is add a post build script. And that's going to look something like this, where we're going to go ahead and make a directory in the root file system called tty1.service.d and add an override.conf file to that directory. Okay, and we can go ahead and write that out. Now we want to make sure that this is executable. So we go ahead and change the permissions here in the file we just created. And we can see there that it is now created. Okay. So the final thing that we need to do here is, because we are specifying a device here as the Pi4, we need to make sure that the project has a Pi4 device subdirectory. Okay. And so what I'm going to do is cheat a little bit here and copy the device directory from the top level. And then I'm going to go ahead and rename this directory to Pi4. And that's how this works. Okay, so now we have a Pi4 subdirectory in our project. And if we look at the full structure here, we have our options, we have config, device, and image. And in our image, we have a post build script that's going to write out some custom configuration that's going to log in automatically the MacMind user. So what our image should include in the end is a MacMind user that gets auto logged in. So we ought to be able to build this now. And the way we're going to now build this is we're going to tell the tool that we have this options file, but we also are now going to tell it that we have a project directory. And we're also going to tell it that we have configuration, and that configuration is called MacMind. Okay, and so this is going to inform the tool of all of what we needed to know in order to build the image that performs the auto login. And here we go. So we're going to go ahead and cross fingers that this works and does everything that we hope and expect it to. Let's go ahead, and you can see how quickly again this is happening. We have a great workflow here. We are on our Mac. We're not using the Pi to do builds. We are configuring, so we're casting the image instead of whittling it and writing scripts to whittle a base image. We can see it's very fast, and this is everything that we are hoping for if we want to build custom Raspberry Pi images. Okay, so we see that this is almost done. All right, and just like that, it is completed, done. Okay, pretty cool, huh? All right, so now again, we have MacMinds.img, and I'm going to go ahead and I'm going to remove the previous image that had the same name. And again, if you recall, we have to go ahead and copy this out of the container to our local machine. And it's just the same command, although the container ID is going to have changed there, right? So let's go ahead and change this container ID. Okay, we ought to be able to copy this guy out. Okay, 500 megs, excellent. Okay, and so now what we should be able to do is take our USB that we had, and here it is. We're gonna plug this back into our Mac. Okay, and we're coming back here to the tool, Imager, and we're gonna just reselect this file today at 248. Okay, and choose storage again. Okay, no customization settings, and we're just gonna erase, right? So there we have it. Should prompt me for some credentials. Okay. Okay, and now it's writing that image to a Raspberry Pi. Sorry, excuse me, to the USB stick. And again, it's very fast, right? This is going to depend on how fast your peripheral is. I find the USB to be faster than the SD. I do have an SD card here, a micro SD card with an adapter. And I've just found that this is a micro SD with the adapter. And I can plug this directly into my Mac as well, but a few things. I found this to be just a slower write. And then also getting it in and out of the Pi is a little bit tricky. The way I have this set up, the SD card reader is actually underneath here, like where the DSI cable is connected to the monitor. So that's tricky. Okay, we're done here. And let's go ahead and take this out again. Okay. And now we're going to plug it in here. And let's go ahead and turn this guy on. Now I'm going to actually remove the keyboard completely. I shouldn't need that anymore to log me in. And see what happens. Okay, so we have our screen here. And now it appears to be booting. Excellent. And it's logged in. See that? Pretty cool, huh? All right. Well, thank you, everybody. That's it for this video. Thanks for tuning in and learning about building a custom image using the RPI Image Gen tool. I really hope you enjoyed it and got something out of it. If you did, go ahead and click that like icon. That would really help me out. Also, please let me know your thoughts in the comments section. Is there more you'd like to know on this topic? Other topics you're interested in? I'd love to hear from you. I hope you're having a great day. And remember, don't stop experimenting, challenging assumptions, and seeking the objective truth. I'm Johnny Mac. This is MacMind.io.